Good morning, Kaden. As promised, I wanted to send a few problems to you today. This is coming from, the first one we're going to do is coming from, excuse me, 10.5 quiz. And it is number 4. Let me come down here. I was writing it in the wrong place. So we have number 4 from 10.5. Okay, and this is the one that we were working on a bit together yesterday, and something wasn't settling with me, and I want to go and do it again, which I'm glad that I did, because I was missing one valuable piece of information that I didn't catch the first time I was doing it. And so the answer that we thought might be it was not. So let's go through this and see if we can identify some very important parts. Now remember, in your reference sheet, and if you don't have that, you might want to pull that out and get it close to you so you can follow along as well. But I like how they do this because for the hyperbola, and actually for all the conic sections that we have studied so far, he makes one of these reference sheets for us, and you'll notice that there's 2 columns here. Actually, there's 3, but I'm talking about the second and third one, so really just focusing on the last 2. That middle column there, x is the major axis. If x is your major axis, then you're going to follow all of this information here. If y is the major axis, then you're going to follow all this information here. So we need to determine which is our major axis. That's the very first thing, because that's going to lead us to which column we're going to be following the information from. So let's see what we're given here. Now, in this problem, we're actually given the equations that we're going to choose from. One of them is correct. And so from that equation, we can actually, or from the information that is given to us up here, where we have our center and our 2 vertices and equations of asymptotes right here, those pieces of information are enough to help us build this equation for this hyperbola. So we need to determine then which is which. So the first thing I want to do is look at the points, and I wanted to stack them on top of each other because I want you to see how this works and how you can see the change in the graph. All right, so we have our center at 3, -10, and I've actually graphed that over here. You can see it on the graph to the right there. It has a little C below it. That's at 3, -10. And then the vertices are also graphed at 9, -10, and -3, -10. So you can see that from the center, it's 6 to the right and 6 to the left, right? So 6 to the right and 6 to the left. Okay, that's where our vertices lie. Now, take a look here. Take a look here at our center that's on top of those 2 vertices. I want you to notice which value, is it the h or is it the k that is changing? And by the way, don't let the h and the k throw you. It's the same as being x and y, but when you're dealing with conic sections, we call them h and k because in the equations themselves, you're going to notice that there are already an x and a y value that have another part to play in the equation. So rather than get mixed up with like calling 2 different parts of it x and y, we only call one part of it x and y and the other parts h and k. So our center is h and k, but keep in mind it's a coordinate point. So it's the same as thinking as the values for x and y, okay, like we would normally plot. All right, so let's take a look at our h and k values and determine which one is changing. So from the center to the vertices, you can see that the k value is very steady, right? It's at -10 in all 3 points. It does not change. But look at our h value here. It does change. And we saw that on the graph where it changed 6 to the right down here and 6 to the left. Okay, so it is our x value or our h value rather that is changing. And because of that, that determines which axis is our major axis. So since this can also be thought of as our xy coordinate point, we're going to call this our x-axis. So our x-axis is our major axis. That is important because when we go up top here, we want to be sure that we're pulling everything from the correct column. So in this case, we're going to be looking at the column for x being the major axis here. So I'm going to highlight this in yellow here. All right. Now, there's a couple things I want to point out to you about the difference between those major axes. If the x value, excuse me, if the x is the major axis versus y being the major axis. So let's look at some of the quick differences so that you can see. If x is your major axis, x will come first. If y is your major axis, look over here in the y column, y becomes first. Why is that true? Well, because your x in the, as far as the major axis, if x is your major axis, x has to be positive. Okay, so this whole value here, x minus h, that's in parentheses being squared, is a positive value. How do I know that? Because this thing is being subtracted. And when you're subtracting, that makes this whole thing over here negative, right? So all of that's considered negative. So your major axis will always be listed first. So x in this case is what is going to be listed first, okay? Just a good note to keep in mind. All right, so let's look at some of the things that we have that are given to us. Let's see, did I put these down here? I want to show you how these are going to look as well. So down here, these are our vertices down here for our hyperbola. So we know they're going to go this way. And also, keep in mind that when x is your major axis, your hyperbolas are going to shoot from left to right, okay, as opposed to being up and down. Okay, another thing is keep in mind that the subtraction sign makes these hyperbola, each one of those, face away from each other. Okay, when we had an ellipse, and if you remember, the difference between the ellipse equation was this one simple change right here. The subtraction sign, in an ellipse, this was a positive. They are added together. So it didn't really matter which order they were in because both of them would be positive, okay? But in the hyperbolas, because they face away from each other, the subtraction sign is the thing in the equation that makes them face away from each other. Remember in the ellipse, and I know we talked about this maybe 2 different times, an ellipse faces toward each other, right? And eventually they're going to connect, making that ellipse, okay? So anyway, let's get back on track here. So we've established that x is the major axis, and we know we're going to be pulling all of our information from. So the first thing I did is I went back up here, and I've already done it. I grabbed the equation right here, and I wrote that down because I want us to see the parts that we need to fill in. Okay, so let's go do that. So here we have x minus h squared over a squared minus y minus k squared over b squared. So let's grab what we have right now, and I'm going to change the color of this so it stands out. So we have x minus, and I know my h value for my center, remember this part is always the center in this equation, and it's going to be minus 3 squared over a squared, but I'm going to leave that denominator blank because we're going to figure that out in just a minute. Minus y minus a negative 10, which is going to give me a plus 10 squared, right? That's what our k value is down here. And then that's going to be over b squared, and we'll figure that out in just a minute as well. And all of that is set equal to 1. So how do I find my denominators? Well, this is where your equation for asymptotes comes in. So let's go back up here to the chart. You're going to notice at the very bottom of this reference sheet is the equations of asymptotes. The part that's going to be important to us is going to be whatever reflects where we might be able to come out with some information regarding b squared and a squared. Well, we notice right here that we have b over a. Now, I want you to take a real quick look over there. If y was your major axis, I'm just moving to the right slightly. Look here, it's flip-flopped. It's a over b. So when you notice the cool thing about x being the major axis versus y being the major axis is that everything seems to be opposite, okay? So let's see if we can go ahead and, oh, one last thing I wanted to point out when I was talking to you about the vertices, look here at the vertices here. You'll notice that it is the h value that is changing. How is it changing? Well, this a is being added and subtracted to the h value, which down on our graph is easier to see. Remember, it changed here. It went 6 to the right, and it went 6 to the left to get to our vertices. Okay, so it's running sideways. Our hyperbola is sideways to each other, which makes x is another reason we can see that x is the major axis. So there's a lot of little pointers that come out of these problems to help us to be able to decide which axis is our major axis. But let's get back on track here with our asymptote. So b over a is important to us. So when I go down here to the asymptotes that they gave to us, right down here that I'm putting in a pink square, that's this value right here. So 10 over 6 is actually b over a. And I got that from right up here. Okay? So b over a. So what we're interested in, though, is what b squared over a squared is, because that's the values we need to fill into our equation. So b squared, then, would be 100, and 6 squared would be 36. Now, I want to address this with you because I'm thinking and I'm hoping that your mind is saying, but wait a minute, a squared is always the larger value. So let's see why it looks like it's not. So our a squared is right here, so we're going to put a 36 down here, and our b squared is right here, and we're going to put 100 right there. Okay, so you're asking then, if a squared is supposed to be the larger value, why does 36 actually work out to go underneath the x value, which is our major axis? Well, the reason is because, remember I pointed out before that the subtraction sign changes a lot for us, okay? That subtraction sign is making everything in this part of our equation negative, including that 100. So if you think about it, I'm just going to write down here 36, and this would be a negative 100 because of the subtraction sign. Well, then that does make 36 greater than that 100, doesn't it? It's actually greater than a negative 100. So our equation then for this hyperbola is what we see right here, x minus 3 squared over 36 minus y plus 10 squared over 100 equals 1. And so yesterday, the mistake I was making was between these two denominators. It just wasn't sitting right with me. So I'm glad I went back over that, but now it should be correct. So you need to find that answer above, and it looks like it is this one right here. Okay, I hope that's helpful today. Have a good day. I'm going to be sending you a couple more problems, so be on the lookout.